Good morning. A warm welcome to all. Today's webinar, Kolkata East-West Metro Project Challenges by Dr. Lakshmana Rao, DGM Afcons Infrastructure. I welcome Chairman Sundarao Garu and office bearers of the association. I welcome today's speaker, Dr. Lakshmana Rao, DGM Afcons Infrastructure. Welcome, sir.
Thank you, sir.
Coming to today's webinar, the project Kolkata East-West Metro Project covers a length of 10.8 kilometers, starts from the station Pulbagan to Howrah. The underground section construction was taken up by two companies and Afcon Infrastructure is one of them. A length of 625-meter tunnel stretch will go through Hooghly River at a depth of 30 meters from the ground level. The deepest midshaft, 45 meters deep, just beside Hooghly River as a part of the project is one of the highlights. It is the first underwater river tunnel of South Asia. Two tunnel boring machines named Rashna and Prerna, inspired names of the daughters of the Afcons employee, were used to complete the project. Since the project tunnel passing below the many buildings and heritage structures, it faced many challenges to complete the project without disturbing the existing structures. Without late, I request Engineer Badan Sundara Garu to take over the session and invite the speaker by reading the biodata.
Thank you, Durga Prasad Garu. Thank you, Dr. Lakshmana Rao Garu, to accepting our invitation and to give a presentation to our members. And I am very thankful on behalf of ACCI Kakinada Center and on my own behalf. About Dr. Lakshmana Rao Mantri. Dr. Lakshmana Rao qualified from IIT Kharagpur, have designed over 50 infrastructure projects within 18 years, have designed the highest retaining wall and received Best Design Award in Asia. He was an expert committee member of Ministry of Geotextiles for 5 years and received Achievement Award from Ministry of National Highways in the year 2018. Contributed in formulation of codal provisions in Indian Road Congress and Bureau of Indian Standards. Received highly esteemed Sir Mokshagundam Visvesvaraya Award from State Government of Karnataka in 2014 for providing engineering solutions with respect to landfills to minimize groundwater and air pollution, and also achieved Sir Mokshagundam Visvesvaraya Award from NGO in Hyderabad in 2020 for adoption of green technology in various sectors. Honored with National Award from IRDP for first underground metro tunnel below river and deepest mid-ventilation shaft in West Bengal. Designed one of the largest ground improvement systems to store crude oil and first wrap around embankment system for flood protection embankment in India. Dr. Lakshman have published over 20 papers in various journals and conferences which are peer-reviewed. Being a passionate and enthusiastic civil engineer, he has been invited by reputed institutes to share his practical field experiences to empower young engineers. He also nominated in the committee B3.4 guidelines on design of underground earth retaining structures, which is under progress. He also jury board member of Civil Engineering and Construction Review Journal. Thank you, sir, for accepting our invitation. Now I request Dr. Lakshman Garu to take over the session, sir.
Yeah. Thank you, sir. Thank you for the introduction.
Sir, thank you.
A warm welcome to all of you. I hope my screen is visible to everyone.
Yes, sir. Visible, sir. Visible, sir.
Yeah. So this is one of the challenging project which we have executed at Afcons infrastructure. So I will take you through brief overview of the project and the challenges which we have faced and how we have overcome the problems. So the flow of presentation will be the introduction of the project and what about the geological conditions along the project alignment and various challenges which we have experienced during construction of the India's deepest metro station. And also we have experienced a few challenges which we have overcome for the tunneling below Hooghly River, which is again the first kind of project in Asia. And also we have executed one of the deepest mid-ventilation shaft just beside the Hooghly River. So there also we have experienced some problems that I will touch upon, and I will conclude with the final outcome. So if you see the project, this is the alignment. In our package, which will start from the Howrah Maidan to the Esplanade station. So this is the first scope of the project in our project, which covers a tunnel of 3.8 kilometer each. That means the total length of the tunnel is around 7.6 kilometers, which comprises 3 stations. So it starts from Howrah Maidan, which is a very crowded area, and it passes through a railway track here, which comes to the Howrah station. Then after the Howrah station, it passes through Hooghly River, and you can see the circular shaft here, which is the mid-ventilation shaft, which was created to give a emergency evacuation passage, because the tunnel length, if you see from Howrah Maidan to Mahakaran, which is far away, so they need a emergency evacuation shaft, which we have created in between. And the third station is Mahakaran station, and from there our tunnel will go to the Esplanade. The station of Esplanade is not in our scope, but the tunnel is between the Mahakaran to Esplanade is our scope. So this is the brief scope of the project. Now I will give the brief introduction of the profile. This is one of the challenging project which we have executed, and also this has a great national and international attention because this project is connecting between Howrah and Kolkata. So far, if you people who are aware of the Kolkata, there is only one bridge which is connecting from Howrah to Kolkata is Howrah Bridge. And there is another bridge was constructed recently that also connect from Howrah to Kolkata. But the major connectivity is the Howrah Bridge. So the rest of the people whoever wants to cross, they generally use the water transport, which will from Howrah and Kolkata. This project being the underground, which will connect and says Howrah and Kolkata, that gives a lot of attention to this project. And besides this tunnel is crossing below Hooghly River, there are other challenges which are old dilapidated buildings. You may all of you know that Kolkata is one of the oldest city in India. It's having the building's life of more than 70 to 80 years. And also there is a heavy old railway offices buildings. And also there is a railway yards. Kolkata, as we know that it is one of the busiest railway station. So we need to cross the tunneling below the railway track without affecting the train movements. And there are many flyovers and bridges below that our tunnels has to pass. And few locations there is a heritage built structures that also we need to protect during the tunneling. These are the various challenges. As I mentioned earlier, this is the first underwater tunnel which was executed in 67 days. Our planned date of days. So I will explain you how we have shortened this time in my subsequent slides. And this is one of the deepest metro station which is having 4 floors. In general, any underground metro station, if you take, we have only 3 levels of slabs, which covers the roof slab, concourse, and base slab. Whereas here, they created an intermediate slab for their property development because this station is connects to the existing Kolkata railway station. So they want to have an additional space for their property development. That way, this become a deepest metro station. And also, as I mentioned in my previous slides, this is the one of the deepest mid ventilation shaft, which is around 45 meters from the ground level, which we have connected. The major challenge is that not only the depth, which is very close to the river. So you can imagine that there is always the water flow from the river to the shaft when we do the construction activities. So there is a challenge from the water egress point of view. So that I will explain you how we have overcome that. So come to the geological profile. This is the broad geological profile, which covers very soft soils. And you know, Kolkata is the groundwater table is almost close to the ground level. If you see around 2 to 2.5 meter from the ground level, you will find the water. And most of the soil is very soft because of the aluminum in nature. So based on the tender stage investigation, we have classified the soil into different layers. The first layer is made ground, which is almost the filled up soil, which is in the loose condition, which is from the depth from 1 to 5 meters, where all the buildings, foundations are resting on these soils only. Because in the older system, there is no concept of the deep foundations or pile foundations. Most of the foundations are with the strip putting, which is again with the brick or masonry, and no concrete was there. So all the foundations are resting on the strip putting, which is in the top 1 to 5 meter soils only. Now that layer 2, which is predominantly silty clay and clay silt, which is below the layer 1, which is also again the soft dark grayish clay. The N values, the SPT N values, if you see, which is ranging from 2 to 8 up to a depth of 18 meters. So that means the 2 to 8 SPT, we all know that if the SPT value is less than 10, we generally call it as a very soft or loose soils. So here 15 to 80 meter up to 18 meter is a soft soil through which we need to do our tunneling. So we have to experience a lot of settlement during the tunneling because of the soft soil in nature, but we need to protect them and we need to move further because the alignment is freeze like that. If we go deeper, then the tunneling may be safe, but it will lead to cost in terms of the tunneling as well as the station constructions. So that's the reason there is no possibility for change of alignment. Now coming to the layer 3, which is again the silty clay with clay silt, with having the better properties. If you can see, the SPT values are ranging from 20 to 30. So which is up to 45 meters. This is a very quite stiff soil. However, we may think that if the soil is good, it is better for our structure. But we have a problem here because of some sandwich layers which are exist in between the clay silt, which carries the water bodies. So we have a lot of challenges. We have faced it. The last layer which we found is a sandy layer, which is very stiff soil, and we found the refusal also. So here, what the challenge we have faced is that all of our station D walls, because the station construction is top-down method. So top-down method is in generally, if any structure, if you see, we always go for a bottom-up. That means we do the foundations first, then columns, then slabs, and go on. Whereas in the stations in underground, wherever the soils are there, we generally follow the top-down construction. That means first we will do the walls, which we'll call it as a D wall. Then we will do the roof slab. Then we will do the excavation. Then we will do the below slab. Like that, we will go from top to bottom. So in such case, all of our bottom of the D wall are going into this stiff sandy soils. So we have a challenge of boring in terms of the piles or in terms of the D wall. So that challenge we have experienced considering the stiff soils. Now you see the another challenge which I told you, the Howrah railway station. So this is the Howrah railway station, which is having around 12 to 14 platforms. And in between these railway tracks, we need to construct the station, which is the Howrah metro station, which we need to construct. Besides this, you have the DRM building, which is around 80 years old, and all railway complex buildings are there, and which is just 60 meter away from the Hooghly River. So this is the Howrah Bridge, which I mentioned earlier. This is the only connectivity between Howrah and Kolkata so far. Now let's see the features of the Kolkata metro, Kolkata railway yard. This is one of the world busiest railway yard. Around 23 live platforms are there. So all platforms together is around 23, and around 673 trains running in a day. So imagine 673 trains means it's almost every minute you have a train is coming into the platform. And more than 10 lakh people are using railway station per day. So the overall footprint per day is around 10 lakhs. So that means the station is, you can imagine how crowded it is. So now let's see what are the challenges we have faced during the construction of this station. So here, the main features is that the diaphragm wall, which I mentioned that this is the station box. And these outer walls, we will call it as a D walls, which will be permanent walls for the station box. And these are the tension piles, barrettes, which generally we will use it for the load carrying capacity during the construction stage. And also we will use it for the flotation check, flotation resistance when the station is floating. So these piles will be for multi-purpose. So the features is the depth of the diaphragm wall is 46 meters with a 1.5 meter thick. And the barrette is 60 meter deep. Barrette means these piles, where my cursor I am moving, which is having 1.2 meter thick. And the piles is around 62 meter deep of 1.5 dia. So that means you can see all these piles and barrettes which are coming in this dense sandy soil layer where we have challenge in the boring. As I mentioned, the depth of excavation for this station is approximately 33 meters. So for this, the first one is that we need to make the D-wall. For the D-wall, we need to prepare a cage. Like how we will make the pile cage for the pile, RCC pile. For D-wall also, we need to make a cage. So for a cage, for this depth, as per the design, the weight is coming around 72 metric ton. So imagine lifting of 72 metric ton is a very big challenge. And also we need to complete this activity within a less time cycle because the soil is tend to collapse. As I mentioned, the soil is very soft. Whenever you do the grabbing, it will try to collapse. So we need to complete the activity within the time cycle. And also we should not disturb the platforms which are existing. You can see this photograph. This is the Howrah station, Howrah metro station, which we are going to construct. These are the platforms. So we should not affect the operations, live traffic. We should complete our construction of the D wall. So this is the typical D wall. So what we have done, this total 6 meter width of single panel, we have done the grabbing as a single. Whereas when we lower the D wall cage, we have split it into two parts. So that weight become now 36 tons, which will be easy to handle it. And also we decided to lift as a single go. In generally what happens, sometimes we will do the horizontal splitting. Most of us know that how the pile foundations will construct. When the pile length is longer, we will make a cage of around 12 meter. Then we will lower it. Then we will put another cage and we will weld it. This is called a splitting of the cage. In the D wall also same way we can do it. But if we do that, it will again take time for welding and all. So we decided that we will lift as a single go. So that means the D wall depth is completely 46 meters. So we have a well-designed procedure for lifting a single cage. For that, what are the required cranes is deployed, we have deployed. And the lifting procedure, you can see we have used the 3 cranes to lift this. This is one, and another cage is holding the cage at center, and third is at the bottom. Generally, what happens, we lift the cage by putting the supporting system at the top as well as the bottom. If we do that, due to the self-weight of cage, the cage can deform. So to avoid that, we have used the third crane to support the cage and minimize the deflections. And also the position of the crane, we have selected such a way that it should not affect the. You can see that we have used only this portion of the movement of the crane, and crane is not allowed to rotate in this direction because these are the platforms. So we have the movement of the crane at this position, and here also we have what we have did that from this initially when the train operations were not, we used to move the crane here and we have to stop it. And also we have what happens when we have done this complete grabbing as a single, then when you lower the 2 parts, it is not necessary that the cage will go straight vertically because this trench is filled with polymer. So due to the buoyancy and all, this cage can move laterally and it can go as inclined also. To avoid that, we have used a steel pipe in the center to guide this D-wall cage to go vertically down. So that way we have made the 2 cages lowering in a single grabbing, which has helped us to reduce the time and also the quality of the work. So these are the few pictures during the lifting and installation of the cage. Now the problem is, another one is the lifting of the stop end. Because if you see my previous slides here, these outer 2, we will call it as a stop ends. Because once we do this grabbing, till you do the cage lowering and concreting, this surrounding soil should not collapse into the trench. To do that, we provide the stop ends, which will temporarily retain the soil. As soon as we do this concreting, we need to lift this stop end, which is nothing but is a casing pipe in our piling, which is similar to that. But imagine that lowering the casing of 46 meter and lifting that, it required a huge force to remove the stop ends. So for that, what we did, we have not lowered the stop end completely till the bottom, and we have limited to a depth where the stiff soil we found. So this helped us to reduce the weight as well as the resistance between the stop end. And also we have used the box type stop end, which is generally, if you see 2 circular pipes are there here. So we created a hollow section. In this we have inserted a pipes. Then what we did, instead of lifting the stop end, when we go for a next grabbing, because this D-wall is a continuous process, this panel is completed and now the grabbing is going on the right side panel. When we have done the grabbing of this, using those pipes which I have shown my previous slide, we have just laterally hammered so that because the soil is removed, it has loosened. Then it is easy to remove the stop end. So this is the process we have established to reduce the force. And also we have made the special case detailing when the joints are there to reduce the water seepage, because our station should be water tightness and also it should be durable for 100 years. So with this, we have avoided the heavy jacking arrangement, which generally we follow for any underground metro project. Now the another challenge is, this is the station box of the Aura station, and the magenta line is our tunneling. So this is the one tunnel, and also the another tunnel is the blue line, second one, which comes to the station and it has to pass through. Now see, these are the head walls. We will call it as a station head walls, where the tunnel comes and hit the D wall. And the other end, the tunnel has to break through and it has to pass through out of the station. So imagine if we do the D walls here, what will happen? Our TBM will come and it will stop there. The TBM has to cut the D wall and it has to pass through. So the main drawback of our tunnel boring machines, it can cut the concrete, but it cannot cut the normal HVSD reinforcement. So in such cases, generally we will provide the GFRP, glass fiber reinforcement, which again, no manufacturer available in India, so we need to import, so which takes a lot of time as well as the cost. So what we have done, this is the zone where, imagine these are the two D wall panels on the head wall. This is the area where our TBM has to cut the D wall. So in a technical word, we will call it as a soft high zone. And this is the tunnel Kakinada. So here, because of the station has to bore through, what happens by the time the TBM reaches to the station, we are not completing the station box. We are only completing the D walls. So that TBM will cut the D wall and it will keep on go and it will move out of the station box. So in the area, we have used these soft type panels, as I shown in my previous slide. We have used the thermocol, which is available, and we have made a frame and we have installed in the D walls. So instead of conventional reinforcement or GFRP, we have used simply the thermocol with a supporting system while casting the D walls, so that it is easy to cut the TBM, these thermocol, and move forward. Now the major challenge we have faced in the station is the water ingress in the station construction. So as I mentioned earlier, if you see in the stiff clay, there are the pockets of sand lances, which having the huge water bodies. So what happened when we have gone for this is the geological profile at particular the Aura station. So now you can see the soft clay, stiff clay, and dense fine sand, where predominantly our station box comes in this stiff clay, whereas our D walls and barrettes and tension piles will go into the dense fine sand. So this is the schematic view of our station box excavation. Now what happened due to this dense fine sand, there is a confined aquifer which is applied as a upward water pressure. Because as I mentioned, the water table is almost close to 3 to 5 meters from the ground level. And also as it is close to the Hooghly River, and this layer is connected to the Hooghly River, which we were not anticipated during the investigation stage, which has created a lot of hydrostatic pressure on the base. So we all know that in terms of the geological parameters, this thickness of the clay layer may go for a heave. So this is the groundwater table, as I mentioned, which is almost 1 meter from the ground level. Now see this circular portion where I marked it. This is critical, because whatever the upward force is coming, the downward force is not sufficient. So at this junction, the buoyancy effect is acting more. So when you calculate the resistance, the dead weight versus the upward pressure, which is less than 1. That means the moment if I excavate up to this level, this soil will collapse and all the water will come into station. So this is what we have our design assessment initially. So to overcome this, as I mentioned again earlier, it is the heave will form like this and the soil will fail, collapse. So to overcome that, what we have done, we have designed a dewatering wells, which will dewater the groundwater so that the water table can reduce, so that the buoyancy effect can be minimized. So for that, we have installed 18 dewatering wells and we started pumping. So the dewatering has done almost 6 to 7 months continuously, but not a single meter drop of water we have observed in the bore wells. So we are keep on dewatering, but there is no drawdown is expected. So then we surprised that why it is happening, because we have used the capacity of the pumps is almost 15 HP, 20 HP pumps, but still the water table is not reducing. So we decided that, okay, let's go ahead with the construction. Then we started excavation and we have completed the concourse slab. Then we found that once the excavation goes below the concourse, it will be a problem for us. So this is the lower concourse level and this is our base slab level. So this is the indicative borewell where we have used for the dewatering. So we have done the excavation up to almost close to the base slab level. Then we have gone further excavation. Then what happened? Suddenly there is a water egress and this is the condition of the station. The entire station is flooded. So suddenly the water was ingressed from the bottom as we expected, and it has flooded the station completely. So immediately we don't have any other option what to do. There is no further thought process. So immediately we have backfilled with the concrete and we bring it back to the original position. So this was the challenge. So now we have gone back to the assessment why this sudden water ingress is happened. So we have carried out a technique called YY analysis. In this we found that one is that the bore wells are failed because we keep on dewatering, but there is no drawdown is expected. So what could be the reason? So one reason could be high water flow, and another reason could be the incorrect permeability estimation. In generally, we always calculate the laboratory permeability as a vertical permeability. But in the soils, we have the two kinds of permeabilities are there. One is the vertical, another is horizontal. So horizontal permeability in this case is higher than the vertical permeability. So the assessment of the number of dewatering wells or capacity of the pumps were on the lower side because we have considered the vertical permeability in our estimation. And also we have not carried out the water pump out test to see what is the effect of this dewatering before start of our construction. So this we have not carried due to the shortage of the timelines and all. And also there is an inadequate geotechnical investigation because once we get the project, there is always a pressure from everyone that we need to start the work immediately. So there is no enough time was given for carrying the detailed investigation. So most of the investigation which we have depended on the tender stage boreholes and we have proceeded. Now another problem we have found that the borewell strainer rupture. Here what happened due to the huge pressure, whatever the pipes which were provided in terms of the PVC, which was completely broken. So we thought that it would be a steel members, it will have a better performance. And also high water imbalance in the borewell pipes. And also the perforated pipes we have installed throughout the length. We can another issue which we have found it. And also we are not able to find the exact location of the intermittent dispense sand lenses with the water because we have only limited geotechnical investigation. So from these two assessments, the final conclusion we derived that the provided investigation data is not sufficient. We need to go for a detailed investigation. Then we have carried out almost 12 to 16 boreholes in and around the station box. Then we have a detailed soil sample collections and we have tested in the laboratory for the various parameters. Then we made the final geological profile assessment. If you see here, earlier the bottom of stiff clay is 43 meter as per the tender stage investigation data, whereas in our actual investigation we found it around 47. So there is a improvement we gained around 4 meter. So which is helped us, which reduced the confined aquifer compared to the tender stage. So this is the one identification we have done. Now we have calculated the factor of safety assessments in the both cases. So here it is less than 1. And also what we have done in earlier when we have calculated the heave calculations, we have not taken any consideration of the shear strength of soil, because there is a bond between concrete and soil. But unfortunately, our Indian codes doesn't say that you have to take into consideration when you calculate the heave. Then we have gone for the international references, and we found in a German code, they have given the provision that you can take the contributory shear resistance of the soil while calculating the heave. Because if the soil has to heave and it has to fail, it has to break its shear resistance. So that also we have taken into consideration. With that, we found that the factor of safety is more than 1. We don't require any dewatering wells. Because the major problem is happening once you do the dewatering, all the wells are punctured through this clay layer into this confined aquifer, which is having high groundwater recharge. So we decided that no dewatering is required. We can go with the construction as normally we do. So now the challenge is that how to plug the bore wells. So we have done the bore wells of 18 numbers. Now through this the water is coming. So we decided to plug the bore wells. So to do that, these dewatering wells, whatever the stones we are filling in these pipes, it is throwing out because of the pressure is too high. Then what we did, we have gone to the concourse level. Earlier we tried at this level, but nothing, we are not successful. Then we reached up to here, we extended the pipes, and through this we have filled the aggregates, and we have left to 25 mm dia zinc. Through this we have done the TAM grouting. So by doing this grouting and all, this entire area is plugged. So after that, we have started with our excavation procedures. So you can see the right picture is the original problem where when the water ingress was happened. And after we have plugged all the bore wells, and this area is completely dry. The left picture shows that the excavation can be done without any dewatering wells. So we have taken a small patch of a small portion of the base slab, and we have excavated up to the base slab level, and we have done successfully completed the base slab. So based on the dewatering system and the ground improvement, whatever we thought, like dewatering wells and all, the planned days was around 280 days, which we thought that we will complete the complete base slab. Whereas due to this plugging of the bore wells and by re-engineering, we decided that this dewatering is not required and all. So we have taken up the base slab excavation, and we have completed within 189 days, which helped us in reduction of time by 32%, and heavy pumping system is avoided, and the subsurface drainage also avoided, and most importantly, the slushy condition at the base slab level is completely eliminated, which helped the team morality is improved. So with that, you can see approximately 53,000 cubic meter of excavation and 2,700 metric ton reinforcement fixing, 16,700 cubic meter concrete we have done in almost 6 months time in a difficult situation. So after completion of that, these are the limelights in paper. So there is a tweet from Ministry of Railways also, because considering this is one of the deepest metro station, so Ministry also has the high intention in this. Now come to the another challenge which we have faced at the construction of mid ventilation shaft. So this is the typical cross section. These are the two tunnels. Between these two tunnels, there will be a cross passage. From this, if any emergency happens, the people will be evacuated through this, and it will come to the surface. And also this mid ventilation shaft will be used for the supplying of air, cool air and all. So there was a ancillary building which was constructed on the top of this. So this is around 36 by 14 meter, and the shaft is 44 meter deep. So the shaft dia is 9.7 meter, which is very close to the tunnels. So initially we thought that this we will do as a well sinking. This is the typical plan view. you see the features of this. There is a railway track. These are the railway tracks which is existing. Local trains will run along to this, and this is the area given to us. And in this, we need to construct the shaft. And this is the flyover. And below, if you go 80 meters from this side, there is a river, Hooghly River. So here, initially we thought we will go with the well sinking. But we thought that well sinking, if we do for a 45-50 meter deep, we are not sure that the verticality of that. If there is a small tilt or anything happens, then our tunnels will be in problem because the tunnels are very close to this shaft. So we decided that let's go with the D wall, as you saw in this yellow color here. These D walls we have used as a temporary D walls, and we have again adopted the top-down construction method with a circular ring beams, which a lifts of every lift is around 1.5 meter, which this we have connected with these D walls. So this concept we have adopted. However, because that given land is completely again as a old factory or some workshop, we are unable to do the D walls as we planned. If you see, it is a perfect shape, perfect square. But while execution, there was some boulders found in this area. We supposed to go straight, but we are unable to go. So we have taken the D wall panel backside. Similarly, at this junction, again there is a boulders. So we are unable to do the D wall till the required depth. So we have made one backup panel on the backside. So with the experience of our station, here also initially our thought process was the dewatering wells, but we have eliminated that. Instead of making the dewatering wells inside, we have made this time outside, so that it will not harm anything even if we do the dewatering. Now the challenge is that, as I mentioned earlier, these D walls, where there is a slight gap between the D wall joints, and again through this, when we started excavation, then the water with soil came into the vent shaft and it's completely filled. And there is a huge settlements at the railway track this side, which is almost 300 to 350 mm has gone. So immediately that has restored, because that is again the live track, so we cannot stop the operations. So we have done, and we have backfilled this shaft till the ground level. Then we have decided, we have again done the re-engineering. Then we have done the jet grouted piles. All this blue and yellow, you can see these are all our jet grouted piles to make the joints impervious. Wherever the D-wall joints are there, these are the joints which may lead to the water seepage. So we have done the jet grouted piles just behind that, all the joints. Then we have started we have established a checklist. One is that the pumping wells should be outside only, not inside. And we keep monitor the standby piezometers. These all are the preventive measures which you have taken to avoid the problems. And we have monitored continuously about the heap in terms of the settlements and monitoring points. And we have installed the CCTV cameras inside. And we have maintained the videography at the shaft after every lift of excavation, and minute level of examine of the D-wall face. Whenever the excavation happens, we used to see whether the surface is wet or dry. If it is a wet, then that indicates that there's some water percolation. So immediately we need to apply the shotcrete. And we need to measure the water content and the shear strength of the soil for undisturbed samples. And also we have stocked the soil nearby, so that if anything happens, immediately we can backfill the shaft. And we have made one water line from the Hooghly River, so that if any chance, if some incident happens, we can fill with water also. If the soil is, because we cannot stack the sufficient quantity of soil nearby area because of the shortage of the space. So we have stored with water also. For that, we have done a pumping line from Hooghly River. So with this, we have started the excavation further. You can see this is the top down. As I mentioned, these are the lifts of each circular rings, and the condition is dry. and we used to check the inside shear strength. And also we used to apply the shotcrete at every phase of excavation. Then this is half of the way. This is the picture which I have presented here, where the water ingress is happened and the flooding completed. So after that, we have established this method. Then this is half of the way, and this is the completion of the ventilation shaft of 44-meter deep. So this is also again tweeted by the ministry, because of this is the deepest mid ventilation shaft, which is almost equal to 15-story building. So with the difficult challenges, this was completed. Now coming to the tunneling below the buildings. See the condition of the buildings. One side we have the challenge is that poor geology, as I explained, and old and dilapidated buildings, and crowded roads and streets. And the challenge is that we need to do the tunneling below the Howrah railway yard, because when you do the tunneling below ground, for these kind of soils, we used to expect the settlement in the range of 35 to 40 mm. So no railways will allow for the settlement of 30 to 40 mm, because if there is any different settlement between these two rails, then there is a toppling of the train can happen. And if there is a longitudinal settlement, then the capacity of the engine may not be sufficient to pull the train. Of course, this train is coming at a platform, so the speed can be limited. That is the only one benefit we got it, but the settlements is challenge for us to control. And there is a heritage buildings, and there is a flyovers which below this our tunnel has to pass, and you can see the traffic on the flyovers. Few more photographs of the buildings. You can see the reinforcement is exposed of the roof slab, and somewhere the reinforcement is already corroded, and there is a cracks in the walls, slabs, flooring, etc. So the major challenges we have experienced is that Kelvin court, which is that all the railway IRS officers used to stay in this. And as I mentioned, the railway yard and the DRM building, again, it is a 90 years old. And the tunneling below Hooghly River. Then the flyover. So these are heritage structures. So all are there. It's not that a small stretch of tunneling is easy for us. Everywhere, for every 100 meters, we have a challenge. So what we have done that, we have established 5 key parameters. This we have established for tunneling below Hooghly River also. So one is that the tunnel flooding condition may happen during the tunneling. And if any leakage scenario may happen during the tunneling below Hooghly River, and the geology is another challenge. And we decided to do the non-stop mining. For any soft soils, the first and prime importance is that we should not stop tunneling. The moment we stop the tunneling, it will lead to more settlements. So we have to ensure the continuous mining. For that, we need to have the preparation works in advance. And the crew deployment pattern. So these are the 5 parameters which we have targeted to have a smooth tunneling in the soils as well as below river. So in terms of the tunneling, we have done the cutter head intervention, because once we start the tunneling below river, we cannot go for any cutter head intervention. If you do the cutter head intervention, we need to stop the tunneling, mining for 5 days, then the face has to be open. If you open the face, then there may be chance of flooding into the tunnel. So we have done before entering below the river, and necessary arrangements made to carry out the intervention below river if required. For that, what we did, we have made a steel casings ready. So if it is required, we have to drive it, and we have to make the watertight. So that plan was made, and also we have ensured the manlock door, we should be in a proper condition, and the screw gate operations, because this is the one of the area through which the water can ingress. So we have ensured that the work chamber pressure should be proper, and this checks we need to do every day, every shift, before start of the operations. Now coming to the geology. So we have carried out the additional investigation, and also we have carried the geophysical studies here to confirm the investigation what we have done. So we have carried 2 additional boreholes, which confirms us that the tunnel is going below clay, in the clay strata, and the permeability is in the order of 10 to the power of -8. So we expect that there will not be any major water inflow in the tunneling if anything happens. And also these kind of strata, we have done the tunneling before entering into the river. So our crew had experience of that. So the same crew we deployed here, who has done the tunneling in the similar strata. And also we found that there is no horizontal curves in the alignment, because if there is a horizontal curves in the tunnel alignment, that will give a opening between the tunnel segments. That will be the probable access for the water ingress. So we ensure that the alignment should be straight so that the segments will be intact. Then the tunnel crown was around 13 meters below riverbed. Overall, it is 30 meters from the water top. And also, because this is the waterway, water transport, there may be some obstructions may come, because most of the ships they will park it here. For that, they will do the anchoring. So we thought that may be a problem for our tunneling. So that also we have checked it, and there is no anchors, though no ship mooring case was expected. Also, in terms of the materials, we had an advanced plan that all the tunnel segments, whatever is required for this 650-meter length, we have parked near to the station, and all the grease and everything is required for the rails, for the movement of the muck cars and all we have parked at the surface, so that minimum time we have given for weightage for any for a kind of any requirement of the material. As soon as any material is required, it should be available at the shaft area, so that the time can be saved. Now coming to the crew. So for crew, what we did, we have decided that even though it's a little difficult for a workforce, but because it's a challenge work, we should take some decisions which may be hard. So we decided that there is no shift change for the crew till crossing the river. So we have established all the toilets inside of the tunnel, and we used to arrange the food for them for all the shifts, but the crew should be stationed in the tunnel itself. And also we decided that minimum watch crew inside, so that if anything happens, there will be less risk. And standby staff and managers will be always there at the surface as well as the bottom of the shaft. And screw grate operated and checked and documented before start of the shift. And also manlog gate kept free and it's documented every stage. In addition to that, whenever the segments mining is completed, segment is erected, we used to do immediately the primary and the secondary grout promptly, because this will another area where there may be a chance of settlements and water ingress can happen. And secondary grouting done after third ring of interval. So in generally secondary grout we will do once we complete around 25 to 30 rings. But here we have not waited for that. As soon as we completed 3 rings, we started the secondary grout. So this will be a very close grouting process, which helped us to tackle the tunneling in a smooth manner. So this is the final completion of the tunnel below the Hooghly River. So with this, the final conclusions which we have drawn in this part is that for any underground metro project, we should have the detailed geotechnical investigation, we should identify the critical zones. And also it's not only the conventional investigation, we should be accompanied with the we should validate those investigations by doing the geophysical studies, so that you will have a confidence that the whatever the geological profile we have assessed, which will be in the proper. And we need to give the due importance during the design stage, which is one of the lagging in our Indian construction field. As soon as we get the project, the day one we want to start the work at the site. But that is not the correct approach. There should be enough time to be given for proper planning and design. Then you can have a proper establishment of construction methods which we can take up. And another thing, we have to give the due importance on the methods and sequence of construction. Because for any underground metro project, the sequence or methods of construction is very, very important. And we need to assess the structures well in advance, and the necessary precautionary measures should be in place. In addition to all the above, there should be a proper coordination between various departments, because here you have the design, execution, as well as the safety and your TBM operator. Everybody should be in a one common agreement. Then only the things can go in a proper way. So with this, I conclude my presentation. Thank you all for your time.
Sir,
We'd
thank
like to
you.
answer if anyone have questions.
Thank you very much, sir.
Thank you very much, sir, for your nice presentation. Sir, can I ask you to show the live foot of stop end, sir?
Live photo, sir. Okay.
Yes, sir. Yes, sir.
This is the stop answer.
Okay, thank you. Thank you.
Sir,
So
this is
if you can see, there is a groove here, sir. Through this groove, we will put the water bar, which will connect between the two concrete panels
Okay, sir. Okay.
for water tightness.
Okay. Okay. Oh, it's very clear, sir. Thank you. Thank you.
this is
One more
Dr.
thing,
Narendra, sir.
While going through your discussion, you told that shear parameters were tested in the laboratory.
Yes, sir.
The problem is dewatering. What is the importance in determining the shear parameters in this context?
So basically, what happens? Whatever the CS, when we calculate the flotation resistance, like heave resistance, we simply take the dead weight of the soil.
Yeah.
Dead weight of the soil divided by the hydrostatic pressure.
Okay.
But when we you can imagine that there is a steel plate. When we apply any load, the plate will first deform.
Yeah.
So in a clay soil also, it is like a plastic material.
Yes.
So before it fails, it has to deform.
Yeah.
And it has its shear strength. Unless the shear strength of the soil breaks, it will not collapse.
Okay. Yeah.
So instead of taking only the dead weight, if we take the consideration of the shear strength into consideration, then you may avoid the requirement of dewatering.
Yes, sir.
Because your resistance will be not only the dead weight plus the shear strength of the soil.
Yes. Thank you, sir. And one more thing, sir. The geotechnical investigations are very, very important. That
Yes.
is true. But with the whatever the test reports you got, those are to be compared during the execution. Do you have any such system in your organization for doing that, sir?
Yes, sir. Generally what we do, sir, whenever we do the either pile or D-wall, when we do the grabbing close to that borehole, we try to collect the samples and we try to compare it.
Yes, sir. Yes, sir.
We may not compare the properties, but at least we can compare the geology, whether the type of material is same as given in the borehole or not.
Yes, sir.
Because once we grab and take the soil, it mixes with the polymer and all. So that samples properties we cannot test, but we can compare the type of soil. That procedure we have it, sir.
Okay, and your engineers, site engineers are trained for that.
Yes, sir.
Yes, That's very, very important. Otherwise, if any strata changes are there and those changes are not observed, there may be a possibility of collapse also.
Yes, sir.
Yes, sir.
Even not only the station construction, sir, even for tunneling also, for
Yeah.
every 1.5 meter mining, we used to collect the sample. We need to keep a stack.
Okay, okay.
That we need to compare with our geological investigation data.
Thank you, sir. Thank you.
Good morning, sir.
Good morning, sir.
Sir, actually, my name is Raghu, and I'm also into this tunneling field. So I have two questions to be asked. Hello.
Sir, yes, sir.
Yeah. First of all, thank you very much for the presentation, sir. It's very good. It's very informative. Regarding the tunneling, I mean, are there any challenges what you have faced during the tunneling? I mean, any water ingress or anything you have observed during the tunneling phase?
In our package, we have not experienced such problems, sir, because we have done tunneling with a proper control and planned manner. But I don't know whether this is the forum to say that the other package was having the problems.
Okay, sir, fine. Sir, can you please also give some details regarding the cross passage construction, what you have done to connect the mid ventilation shaft?
The cross passage construction, what we did it, sir. I will just go to the slide slightly. So when we do this cross passage, sir, what we did is that we have done this entire area as a consolidation grouting. So we have inserted the grout pipes. We used to send the grout, and other side we need to extract the water. So this entire area we have made a consolidation grouting, and we have stabilized. After that,
Sir,
yeah.
Sir, sorry to interrupt. So the consolidation grouting, what you have done, is it from the tunnel inside or from the shaft?
From the tunnel inside, from inside of the tunnel.
Okay, and you were collecting the material in the shaft, no?
Yes, yes.
Okay, sir. Okay, sir. Thank you very much.
Sir, what are the softwares used, sir?
So here we have used the Plaxis for all our tunnel designs and all. And for the station box design and all, we have used the Stad Pro and Midas and Wall app.
Okay, sir.
Hello, sir.
However, you ask.
Sir, can I ask you two questions, sir?
Yes, sir.
Yeah. Good morning, sir. This is Dr. Lakshmana Rao, sir. I have actually three questions, sir. One is regarding the problems and the challenges faced by you in this project. Are it different from the previous project that was faced in the first phase of this underground metro of Kolkata that was done by Professor N. So?
Yes, sir. Fortunately, the phase 1 underground metro in Calcutta was also done by Afcons only. But there the method of construction is different, sir. It is there we have used the shield tunnel. It is mostly cut and cover.
Yes, sir.
Whereas here we have used the tunnel boring machine. So there is a difference in the construction methodology, sir.
Is it that changed to the difficulties that was faced?
Yes.
Yeah. The second question is, sir, you have highlighted the.
However, your voice is low, sir.
Okay.
I have some sneezing problem is there, sir. Now clear, sir?
Yeah, it is clear, sir.
Sir, you have highlighted the jet grouting, sir. For the jet grouting, for the leakage of the D-wall joints and all that. What is the pressure that was adopted, sir? And also, what is the type of grout that was adopted?
Sir, can you repeat the question again?
The jet grouted piles you have mentioned, sir.
Yeah.
For the jet grouted piles, what is the pressure of the type of grout?
Okay. So the pressure we have used around 2.5 bar. We have used the sodium silicate and cement mixer to form a jet-coated column. And we have done some trials before we proceed with the actual work. Then we have extracted the core samples and we have tested for the strength, which we have achieved 1.5 MPa. And also we have done the water permeability test through the core. So which has also given the permeability is 10 to the power of minus 11 meter per second. Centimeter per second. So after that only we have gone for the actual work. Is it clear, sir?
Lakshmana Rao garu.
I think sir might have some problem.
Hello, sir.
Is it clear, sir?
Yes, sir. Clear, sir. Third question is there, sir.
Yes, sir.
Yes. One more question is regarding the permeability value of the testing. You have rightly mentioned
Sir.
that there is a much difference between the horizontal and the vertical permeability. Hello, sir.
Yes, sir. I can hear you, sir.
Yes, sir. Generally, theoretically speaking, there is a 10 to 1,000 times difference is there, sir, between the horizontal and vertical permeability. We have a similar problem we are designing, sir, in that the question of this horizontal and vertical permeability has came into the issue.
Yes.
What we suggest you is, in a general sense, as a researcher point of view, I'm saying, sir, the soil anisotropy and the direction of permeability, to account for that, it's simply better to have the direction of the sample reverse in the laboratory point of view, beside the field test. That gives a better results in giving the horizontal permeability values, sir. Yeah, in the laboratory point of view, we get the vertical permeability that is true in the direction of the sampling. But once the sample was reversed, and that is the sample is taken in the perpendicular direction to the axis of the sampling tube, that gives the elastic value of the horizontal permeability value of the sample, sir. And also,
Yes, sir.
it is better to have the field tests in such a large project, sir. I hope so. You have conducted some field tests also.
Yeah, I agree with you, sir. That's the reason I specified that. Unfortunately, we have not carried out the field pump out test to assess the permeability.
Right, sir.
But your point is valid, correct, sir. That horizontal permeability we need to do it as you mentioned by tilting the sample by 180 degree.
Yes, sir. Right, sir. Thank you, sir. Thank you, sir.
Thank you, sir.
Sorry, any questions from the participants? Sir, one question is posted in the chat box
Okay, sir.
from Sarvanan. Any additional care taken by you for natural disaster like tsunami, earthquake, heavy waves during design stage?
Yes, sir. For the design stage, generally we will take it for the all the stations and tunnels. We will design for the seismic. And as Kolkata comes under seismic zone 2 or 3, we have taken that into consideration. In addition to that, to answer that national disaster and all, whenever we design the station tunnels, we generally consider for a flooding condition. That means we considered 1 meter water table above the ground level. For that condition also, we check the design. And we always limit our structure crack width is 0.2 mm. Less than 0.2 mm. So that the permeability through water, which will be less, which can be pumpable to the surface if any seepage happens. And we check the durability of the concrete for 100 years. For that, we carry out the permeability test as well as the RCPT test on the concrete segment. The permeability for concrete should be less than 10 mm per hour. and the RCPT should be 1000 coulombs as per the Mortar IRC classifications.
Sir, one question posted from Mahesh. Are there any code apart from Indian standard adapted for testing and construction activities? Apart from Codal, is there any professional practice utilized to mitigate the challenges?
Basically, these underground projects, each project has a unique. Whatever the challenges we may experience now, which may or may not come in the other projects. But there is a guidelines which are available in ITA guidelines, which we'll call it as International Tunneling Association. If you can go there, and there are a lot of examples and challenges which they may face, that they generally publish in the form of manuals that can be referred.
Okay, sir. And one more question, sir, by CL. I have observed that the design is from Plaxis software. Any seismic performance analysis is done for the project?
Already explained.
Explain.
Yes, sir. We have carried out the seismic analysis.
Any questions from the participants?
Last question, sir. Sir, Dr. Narasimha speaking, sir.
Yes, sir.
Sir, regarding the Plaxis analysis, have you carried out the total stress analysis or the effective stress analysis?
Both we have carried out, sir, because in some cases we have the short-term stability requirements. For example, like when I do the tunnel mining, till we erect the rings, the permanent RCC rings, the soil has to stand. So for that, we have taken the total stress condition, whereas for the long-term behavior, we have taken the effective stress conditions.
That is after the completion of the construction.
Yes. Yes.
Thanks. Thank you.
Sir, good morning, sir. Sorry, one last question. Is it possible to conduct the seismic performance analysis even for a landslide, sir? Through your experience, kindly elaborate.
For landslides?
Yes, sir.
Yes, sir. Landslides also we can do it, because now if you see most of these embankments and hill slope retaining walls and all, we are carrying out the earthquake seismic analysis.
Sure, sir. Thank you, sir. Thank you so much.
One more question is, sir. On which part the StatPro is used, sir?
For the design of the station box.
Okay.
We have taken the forces from the wall lab. Then we have designed the station like slabs and other elements which we have used the StatPro.
Any questions? I request the participant to ask the questions. Okay, sir, we are closing the session with my vote of thanks. I would like to thank ACCA headquarters for the support and encouragement. My sincere thanks to Dr. Lakshmana Rao for spending his valuable time for our association. My thanks to all ACCA members, faculty of engineering colleges, co-engineer friends, managing committee, and our member Sairam for his support. Thank you all. Thank you.
Thank you, sir. Thank you so much.
Thank you all.